Let's kick it off. Hello everybody, my name is Philippe Ozil. I'm a developer advocate at Salesforce, and you're here today because you're interested in learning about UI testing or end-to-end tests. And today I'm going to talk about a technology that Salesforce is bringing to you called UTAM, or UI Test Automation Model. So I've been working with the company for about 7 years, and I specialize in everything that is platform related. And this tool that I'm going to talk about works with platform, but you can also use it for other needs, for other types of tests. So I don't need to do the forward-looking statement that we normally do, because this is not exactly part of the commercial offering of Salesforce. This is an open source tool that I'm going to present that can help you test on the platform. What we're going to do today is we're going to start with a level set on what is end-to-end testing and how it compares to the other types of tests. Then I'll talk about the technology that is UTAM. I'll show you some demos about how you can run end-to-end tests with UTAM, and I'll show you a couple of tools that you can use to get started fast with this technology. All right, let's do a little refresh. You've probably seen this pyramid a couple of times already. This is called the test pyramid, and there can be different levels, but essentially the idea is that you have a hierarchy in the different types of tests that you need to build in a project. The lower level being generally unit tests, so tests that are pretty small and short to run. These are working in a white box so-called model, because when you do unit testing, you have access to the source code. So you know the implementation, you're testing just source code at the lowest level. You can do that on the platform, for example, in Apex or in any web components. And then the upper level that you have is integration. When you do integration, you test not only your code, but also integrations with external systems. Like, for example, if you have an external data source, or if you have a web API that you're calling, this would be the type of test you cover in integration. Finally, now you start moving up the pyramid. Finally, you get to the top of the pyramid, which is end-to-end testing. So you can also say, for example, functional testing or UI testing. But the top of the pyramid, that is end-to-end testing, works in a black box model. And what I mean by that is that when you do end-to-end testing, you're testing the interaction scenario that a business user would need to do to, for example, create a record or navigate in your application. You do not test the code itself, so you don't have access to the source code at all in the end. And you could be testing things for which you don't control the source code. For example, if your application requires that you use packages from AppExchange or from other vendors which are not open source, well, you can still do end-to-end testing. Now, why is this shaped in the form of a pyramid? Well, the reason is for practical reasons. Unit tests are pretty cheap to put in place. They're easy to implement, easy to maintain. But as you go up the pyramid, things become more complex. And when you reach end-to-end testing, these are generally the most complex type of tests, so they cost more in terms of implementation and in terms of maintenance. These are important, but you should focus generally more at the bottom of the pyramid, and this is why we call a priority called shift left, which in the pyramid should be more shift down. You should invest as a priority on unit tests. But today I'm here to talk about end-to-end tests, and that's really what the focus is. End-to-end tests are powerful because that's exactly what the end user is experimenting with your application. But again, they're expensive and fragile. So to compensate for that, Salesforce built a tool called UTAM, UI Testing Automation Model. And what we're doing with this tool is that it's open sourced, and we use it actually internally. Salesforce engineering teams are using it to test things like, for example, the Lightning experience. Everything that is Lightning experience based has been tested by UTAM. More and more teams are implementing this. How does this work? UTAM does not replace a test runner. So UTAM on its own won't do the test itself. UTAM is here, in fact, to break down the complexity of a complex page. It allows you to break down a big complex page, like, for example, Lightning experience, into smaller chunks and create reusable fragments. And what we do with those fragments is that we then integrate them with an end-to-end test runner. Things like Selenium or WebDriver.io, these are common tools that you would use, and you use those tools in combination with UTAM. What's great about UTAM also is that it's language agnostic. It doesn't tie itself to a specific technology. You can use it with Java, you can use it with JavaScript, and maybe in the future with other technologies. And now, to put this a bit in perspective, let me show you a bit how UTAM places itself in the test framework. So let's say you want to test a web page. For example, this is Lightning Experience again, maybe the home page of your Lightning Experience. And you have the page, which is the web page that you want to test. And the first thing you'll do with UTAM is that you'll start to decompose this page into JSON page objects. A page object represents a fragment of the page. So this can be, for example, the navigation bar. This can be an individual button. And you have this hierarchy that kind of mimics the way you would have the DOM tree itself. So the application, then the tabs, then the buttons, etc. And so you break down this page into smaller chunks or page objects, and you compose those page objects to represent the complexity of your page. Each of these page objects reference a specific element in your DOM tree. Now, once you have built those JSON page objects, you'll then use UTAM to compile those page objects into the technology of your choice. Right now, we have 3 different technologies that are supported by UTAM, but the compiler can evolve to add more language. We have JavaScript, TypeScript, and Java we can use. The teams at Salesforce generally use Java, but I've been using myself JavaScript, and it works exactly the same. The idea is that the JSON page objects will be looking the same, and you can then compile them in the language of your choice. Once you transform those JSON page objects into native objects, whether it's JavaScript, TypeScript, or Java, you can then use those page objects in your tests. Now, you will use your favorite test runner, Selenium, WebDriver, or whatever, and reference those page objects that have been compiled in your tests. So here you can already see the added value. The idea here is to decouple the tests themselves from the structure of the page. So the test itself doesn't have a reference to the DOM. If the DOM changes, if the structure of the page changes, the test will stay the same, but the page objects will be recompiled with another reference point. And the advantage is that you can have a lot of tests, and they can share the same page objects. So that's really the benefit of UTAM. It helps for maintenance, and it helps also for reuse of components. Now, once you have written your tests with the language of your choice again, the test will run, and the test runner will spin up a browser and will control it automatically to test the different interactions with the page. And that's the theory how UTAM works. And I can show you that in practice. And for that, I'm going to take one of our sample applications called eBike. This is one of the applications my team is building. It's open source. You can find it on GitHub. And it has the particularity of having some UTAM tests built in. What we're looking at right now is a page called the Product Explorer, and it's just a way to show essentially a list of products with dynamic filters. And a tile representation, you could have kind of the same data as a list view, but here we made this look a bit different. And we're going to see how we can test this particular page with UTAM. And before I show you how we can test it, we need to decompose the page into smaller chunks, like you would do with page object, but also as you would do with web components, for example. At the top of the page, of course, you're inside Lightning Experience. Then in Lightning Experience, you have a navigation bar with the different tabs, and then under that, you have a flexi page, which is the host for your Lightning app page, and then you have the ability to specify a template for this page, and then that's where it starts getting a bit more custom. Depending on the template you have different regions in your page. In the example I'm sharing now, we have three regions, and then you have a mix of both base components and custom components. Everything that I shared on the previous page is all custom, so that's custom Lightning Web Components, and you can see them here in orange. And they do incorporate some base components like cards, buttons, sliders, etc. So this is really the structure we're going to test. And what I want to show you here is that there are things that I really do not control. For example, all the upper layer, everything that is at the Lightning Experience level, I do not control these components. I don't have the access to the source code, and I don't know exactly the structure of this page. But what's really cool with UTAM is that since Salesforce is using it, we are shipping, along with the compiler, UTAM compiler, we're shipping the base page object definitions. So each time you have, for example, a base component, you will get a page object that goes along with it. So I don't have to look at the structure, for example, of a Lightning input. I don't have to look at the definition of the app navigation bar. This is all provided by Salesforce as a set of base page objects. And I can just, in the end, write my own page objects for my custom components, the one in orange here, to finish my test. So let's see that in practice. I'm going to switch away from the demo now. Sorry, switch away from the slides to look at a little demo. So now I'm in Visual Studio Code, and I'm looking at the repository for my Emacs application. And now I can go and drill down in my page, and I can look at my Lightning Web Components. Let me also open my org so that I can show you the page itself. In a second, hopefully. Yes. There we go. And so we're going to take a look at the page, just see very quickly how it behaves. It's a bit small. Let me just increase the font size a bit. There we go. All right, so that's the product explorer that I just showed a screenshot of. So the way it works is that you can select some filters. For example, if I type product name, it will filter my product list. If I select a product, I can see the details on the right side. So that's the scenario we want to test. We want to see if we can filter, if we can select elements, and if we can navigate to those elements. What I did right now manually is what I will be testing in this demo. So how do we do this? Well, we first need to take a look at the components, and we're going to focus on a single component here because I don't have the time to show you all the source code, but we're going to focus on the product tile list. This is the tile in the center of the page, and for this web component, you have two subfolders. The first one here, tests, are the jest tests, so these are the unit tests for this specific Lightning Web component. But we're not going to look at this one. We're going to look at UTAM folder here, which contains the the page object for this particular web component. So I have the typical files after that of my component, the HTML, the JavaScript, and I can look at my UTAM page object. So how does it work? It's a JavaScript language, a JSON object that uses some common tags and structure. Here, for example, shadow is telling me that this is a Lightning Web component, so we need to go into the shadow DOM to explore the content of this element, and then we can inspect it. After that, we have a couple of elements, and these elements always have a name. Like, for example, there's a paginator, and if you look at the page, the paginator is this lower part here with the page number, which gets updated dynamically when you have more or less elements selected. You have also then the tiles themselves, and here you can see already some composition. The tile is referring a CSS attribute, which is the name of my tag, but it's also pointing to a sub-page object. Just like the paginator itself, we're referencing other smaller page objects, which I have also defined in my project. So you can see here a bit of composition. And the idea is that we're going to break down the complexity of this page into smaller chunks. And if I were to go down, for example, look at the paginator, which is probably the simplest of the page objects. The paginator is has a couple of hooks, like, for example, the navigation information, and it has the ability to extract text from my navigation bar there. So I can see, for example, which page I'm on right now. So we have our HTML, we have our page objects. Let's run the test itself now. The first thing I need to do is I need to turn those JSON page objects into executable code, so I need to compile them. And what I'm going to do now is actually I'm going to delete this folder page objects because I already had them compiled before, so I'm just going to delete this and I'm going to recompile them. To do this, we have a little script that I have set up, so I'm going to do run test UI compile. And this will take my different JSON page objects. You can see they're here, all my custom page objects. And this has recreated this page objects folder here. Within it, you'll find the different versions of my compiled page objects. So for example, if you're looking at the paginator, I'm going to take, for example, the TypeScript version. You'll see the two methods that we had before, getting the navigation div itself, and then the text of this div. And this is matching what we had in the, sorry, I closed it, what we had in the in a JSON object. So we turn this bit of JSON into an object that we can reuse in our tests. Now, when we run the tests, so in this case, I'm going to use something called WebDriver.io. We're going to be using these objects like the paginator, and we can chain the calls to different objects. Let's actually try to run it. I'm going to do one last thing before running a test. I need to generate a login session. So I'm going to I'm going to run another script, test UI generate login. This will extract a session ID for me that I can use. And then I'm going to run the test itself. So I'm just going to go test UI. And then if everything goes well, you'll see a browser spin up automatically, controlled by WebDriver.io. And this will normally run my end-to-end test. You can see here that this is automated because there's a little bar there on top of Chrome telling me that this is controlled automatically. So it's selecting the page explorer. Oh, well, this worked, but it went a bit fast. So I can actually show you maybe twice. What it did is that it selected a filter. So it typed fused in there. reducing the selection, select the first element, and opened it in another window. So that's exactly what the test does. Let me rerun it because it went very fast. You can see the test is passing, but it was a bit fast. Now, to be fair, the problem with end-to-end testing, whether you're using UTAM or any other technology, is that these tests are dependent on a lot of factors, like the load of the server, the latency of the network, and these tests can sometimes succeed very fast, like this one, or they can fail. And to the difference of unit tests, I would say that a failure is not the end of the world for end-to-end tests. You have to look more at the numbers on the long run. If a test fails occasionally, that's okay, but if a test is failing all the time, then that is more of a problem. So we saw the test. Now let's look at one last thing before I go back to the slides, the actual code we wrote to do the test. So this code is the Page Explorer spec, and this is where I've used my different page objects to run my test. So I'm going to go directly to the test method itself, and you can see here what I'm doing is I'm loading a bunch of page objects, and they're actually in the imports here. I'm using a combination of my custom page objects, the ones that are under this page object structure, and I'm using also other standard page objects as well. They're combined together. And then what we do is that we just chain the different calls. So for example, here I retrieve the application navbar of my Lightning experience. I select my navigation item called Product Explorer so that I can navigate to it. I click on the tab, wait for the Flexi page to load. Then I extract the different sections of my layout, the center component, the right component, and the left component, sorry, the other way around. And then I go and I drill down, looking at the product card, and at some point, this is where I'll get to start to do a bit of interaction. So before I actually click on anything, the next thing I'm doing there is checking the default state. So I'm looking at the pagination information, retrieving the text from this little div at the bottom of my page and making sure that I have all my items displayed by default. So here I already know, because this is a test environment, that I will only have 16 items in 2 pages. And after that, I'm going to start doing some changes to my page. So for example, here I'm retrieving a handle to my search input in my product filters, and I'm starting to type text like Fuse, which is one of the product categories. I'm going to wait for the page to refresh, making sure that the pagination is reflecting that we have a shorter list of 4 items instead of 16. And then we can continue. We can look at the tiles. We can, for example, click on the first tile to select it, making sure that the selection on the right side of the page does indeed reflect the selection. So that's Fuse X1. We already know the exact data set, so we know which one we're selecting here. We could also be using some search on the product names also, instead of just picking the first one randomly. And then we can simulate a click, and et cetera, et cetera. So you see, the way we're controlling the test is that we're using the page objects that we've just compiled, and we're doing some interactions with them. Sometimes it's just reading data, sometimes it's clicking, sometimes it's waiting for something to refresh, but that's the way we work with UTAM. So back to the slides now. Yep, where are we? Oh, no, we're here, behind this. Let me go here. So what we have in what we saw was the way we test the different page elements, but how do you know about the complexity of the page? And that was a bit of a challenge at first. I've been doing this talk for about a year now, and now UTAM has grown a bit in maturity. And at first, it was very difficult to identify which were the correct page objects to use for a test, especially since you're not developing the upper layer of the Lightning experience. So to help you, assist you, guide you, navigate through the different page objects, there's a Chrome extension here that is very handy that the team has provided. And actually, I will just jump to the second part of the demo now. We're going to take a look at something different now, and I'm just going to move away from the pure e-bikes example, and I'm going to show you how you can use this Chrome extension here, I have it installed here, to test my page. So I'm going to just open my developer console here. Let me just reposition it as a drawer below. And you see I have a UTAM tab now, thanks to the extension. And what I have to do is start by clicking Find Base Page Object. What I did before the presentation is that I loaded the Salesforce base page objects. Salesforce currently has around 600 base page objects. You can imagine the complexity of testing the entirety of landing experience. There's a lot of different things we control, starting from, for example, the app launcher, to the tiles, to even some advanced view, like, for example, the landing app builder, and soon also things like flows as well. So there's a lot of different base page objects, not only the lightning component, the base lightning components like a button, but also like upper level components. So to navigate and to find which one I need to use, I have this handy extension here, which will let me identify the page objects on my page. And right now, it's not finding any. Okay, maybe I need to reload them. It's been some time I haven't. Yes, 653, so that's good. They're already there. And for some reason, I don't see. Well, let me retry this again. I may need to refresh. Let me clear them. Okay. I'm going to clear my files, and I'm going to reinstall my base page objects. This is a good way to show you the UTAM web page. UTAM is very easy to remember. It's utam.dev. This is the official documentation page. And when I go in the tools section, I have the first thing is the browser extension, and from there I have the instructions to install it and to configure it. I'm going to go very quickly to the part where I can recompile the base page objects, because the base page objects are updated regularly. For example, right now the team is working on the summer 23 release, so it could be why this is not working. I'm gonna regenerate them, and oh, sorry, this is a bit small, but okay, fine. And I'm going to repack them. So right now they're hosted on NPM, but depending on the technology you're using, you can get them. And here I have an archive that I can use and reload in my page here. So I'm going to upload the archive that I just generated. Oops, in my desktop. There we go. And I'm going to reload them. So normally we have even more page objects, because as the time goes, additional Salesforce teams are using UTAM and are building and shipping page objects. So in a couple of seconds, we should see the page objects being loaded. And after that, the Chrome plugin will help me identify visually on the page which page object I should use. And it will guide me through the sequence I have to go through to drill down in the page and chain the different interactions to, for example, create a new record here with a new button here. So this is taking a bit of time. Hopefully it won't fail. But I would like to show you this, because it's really something helpful that has been released quite recently. The team is still working on the extension. They're adding new features to it, but it's life-changing. Before that, what I had to do and what you had to do was to inspect the DOM tree, and you were looking essentially at the structure of the page, trying to locate what your element is. So you would have to do an inspect, and you would have to understand and look at the structure of the page, go and look at all the DOM tree, and this is of course deep in a DOM tree, so you don't want to do that. But normally, once this finished loading, I should be able to use them and to find a convenient way to select this new button. I don't know if it's going to work, but I hope so. As I said, there are about 600 of those page objects, so this is what is taking a bit of time. It's taking some time to import them and to extract them. And if it's too long, I will just continue with the presentation and maybe go back to it. Well, let me just go back to the slides and let it work in the background, and I'll try to show you that just after. Yes? Aha, that's a good question. Can I do that? Let me try this. Yeah. All right, let me try to close the browser. Let's see. Maybe it's just the refresh part that didn't work. And I have my talk here, and I need to reopen my org. So, shortcut, if you don't know how to do this, you can look at this little open org button here to reopen quickly an org from VS Code extension. Very handy if you didn't know about this one. And now I'm back in my org. Let's see if I can reopen it. Reopening my developer console. Let's see. Going back to account page, and did it work? Oh yes, it did work, thank you. I forgot about this bug, I hadn't been reloading them recently. So the first thing you do is click on Find, and yes, this time it worked. So what you see now on the left side of the UTAM Explorer extension is that you have a number of upper level, what called root page objects. And from there, you can see as I move my mouse over it, some parts are being highlighted. in red. Like for example here, when I select the object home base component, I have my my list view and the wrapper, the header of my list view being selected. So I'm going to use this one, and I can drill down and see what are the methods. So for example, this one is get list view, so I can select it, and I'm going to continue to go and drill down. I can see that I have a header. So for example, I can select the header, and I can drill down, look at the actions, maybe get an action link like this one, the new button here. I can select it by typing the text, because this method requires a name, the label of the button. I can apply, and as I go, I can also go down and finish with click. So here what I did, in just a couple of clicks, I went into my object record page, on my object home page, sorry. I selected the new button and I clicked it. And you can see what is very convenient with this extension is that the code that you need to call here is being displayed for you. So it's showing you which are the different objects we need to call. Except this one is showing actually Java, and let's see, just need to refresh it. We should see JavaScript, for example, or Java, depending on the language you want. This is the exact combination of base page object that you need to call. And right now they're like almost one per line, so like it's like 6 or 7 now just to get to this new button. But with the UI, the plugin itself, it's kind of very easy to find them. Not only does it work right now with the base page objects, so you can see the 600 or so page objects, but you can soon also add your own custom objects. Right now it's only the standard ones. And this works with any kind of layout, provided that the Salesforce engineering team has shipped their own page objects. There are 600 of them right now, and this also includes things like mobile, and soon there will be even more. Back to the slides. So that's a bit, I need to advance this a bit, going back to where we were. Yes, so we saw the Chrome extension. There's also another tool which I will not demonstrate today, but there's also another tool which is handy called the page object generator. Essentially, you take just a snippet of your code that you want to test, and it will suggest for you a base page object. So it will automatically write the JSON for you, allowing you to get the right properties. But it works on the smaller objects, but when the page is too big, it can be hard. So it's up to you. You can explore it, but it's not always easy. Just to wrap this up, so I show you a bit what the framework does, what UTAM does. You saw a glimpse of the technology. I won't lie, it's something that is a bit technical to set up at first, but the advantage of it is that on the long run, oh, I lost the screen, there. Yeah. On the long run, you'll save a lot of time on maintenance. UI testing is never easy, so whether you use UTAM, or whether you use Selenium or any other technology, it's never easy, but what you win with UTAM is really the maintenance on the long run, and the fact you benefit from the work of the Salesforce engineering teams, the one that are building the product or actually shipping the base page object, which helps you save a lot of time instead of re-implementing everything from scratch. In any case, remember that you should focus as a priority on unit tests, and only then after that do end-to-end tests. Now, there's going to be something I haven't written in this slide, but which is going to be a big game changer soon. There's a work in progress for the Salesforce engineering team. They are tweaking a bit the way we build web components as a whole in Lightning Experience. And what they're trying to do is move closer to the pure web standard, the pure web component standard. And we're soon going to adopt something called native Shadow DOM. And if you're using UTAM, the good news is that this is going to be completely transparent, because the engineering teams are working on updating the base page object. But if you are using another end-to-end testing technology, well, you need maybe to do a bit of refactoring in there to adjust for the changes. So that's another added value of using UTAM. And then this number is maybe not accurate anymore. I said 580 page objects. That are probably closer to 600, even more now. And the thing is, that's just for the pure platform, the pure Lightning Experience, but there's no limits to what you can do with UTAM. You can test any page, actually. You don't need to be even on Salesforce technology. You can test mobile interfaces with it. You can test things that are totally unrelated to Salesforce, provided that you write your own page objects. And what's really nice, again, is that you don't need to have the source code of the things you're testing. You can test integration with third-party packages or third-party websites, all of that, because, well, you just have to have a browser, and that's it. You can configure those tests and automate them. That's a wrap. That's what I wanted to share with you today. If you have questions, I'll be happy to take them. Oh yeah, before I forget, resources. I was going a bit too fast. What we saw was the website, the official website, utam.dev. It has a fairly good documentation with some explanation about the different tools. The examples, there's some recipes that are shared there, links. You'll see the different extensions, the Chrome extension and the generator. And I will also share the Git repository that I just presented today, eBikes. There's the demo we just saw with the Product Explorer, but we have also 2 additional repositories which also contains example. One is written in JavaScript and the other one is written in Java, depending on what technology you want to use. You'll see that you can use the same base page objects, regardless of the language. All right, and now going to questions. Thank you. Oh, sorry, if you want to see the resources, I can put back the resources. I went a bit fast. All right, any questions?
So with each release,
take the microphone. Yeah.
So do you get new versions of base components with each release? Is it like?
Absolutely, yes.
So if the underlying style sheets change, they would.
Yep.
And then, is it as part? Is it as part of the Lightning? Lightning pack, or how do you?
Yeah. What I didn't show when I was showing my project is that as part of my dependencies in my project, I have. Let me just minimize this. I have a node project really, and this node project has a bunch of dependencies, and one of them is this, the Salesforce base page object. So the version doesn't really match the Salesforce releases yet. Maybe we will change that in the future, but essentially you have new versions of those base page objects. That is the same thing that I just zipped and uploaded to my Chrome plugin. You get additional packages, which are also versions, which contain the definition of the base components. So whenever, for example, you move from spring to summer release, you'll have an initial set of page objects that you can use in your test. You just recompile them, and that's it. Your test is running. You don't have to modify any test. Right.
So Lightning components where you don't use base components, everything is built from scratch, you still have the same problem having to.
Well, yes, of course. If you're the author of the component, you have to build them yourself. Now, the good thing is that since it's decoupled from the actual test code, there's a lot of reuse. So you have only to fix it in one place. You don't have to look at all of your test code. You just fix maybe 1 or 2 JSON files, recompile them, and that's it. Your tests are running again. To the difference, if you weren't using this decoupling, you would have to look at all your tests, look at all your CSS selectors, and find where do you have to do the updates and do it multiple times for the same mistake or problem. That's really the benefit here. So it's good for teamwork.
One of the problems that we found with end-to-end testing with Salesforce is this combination of 3 things. The async nature of the load means that you have things appearing at different times. The inconsistent performance of sandboxes and scratch orgs then mean that you can't really predict when things are going to appear, and things can slow quite a bit. And then finally, that there aren't any clear hooks that you can reliably attach to say that when something's happened. So if you want to perform an action, to know that that button's there before you try to do it, or is it just it's never going to appear? So that should be a failure.
Yes.
So is there anything in UTAM that helps with that?
Yes, that's what you said is just, it's a good summary of all the problems you face when you do UI testing. The asynchronous nature of this whole thing really brings a lot of complexity. And what UTAM brings here is that the teams behind UTAM, the people who are doing the actual engineering on building the components, have implemented a couple of methods. When I was showing my test, this is one that I wrote myself, but the base pages also have these. And there are methods like, for example, wait for pagination update. And because I'm the one who built this component, I know exactly what to wait for, what is the signal that will tell me that the page has been refreshed. And I can use these hooks, or I would say maybe markers, to wait for something to happen. And some of them are shipped as part of the base page objects. So if I were to, for example, to go back in my Chrome plugin there, what I shared was a pretty direct path to get to the new button. But in certain cases, like for example here, if I open a model to create a new record, you see that it takes a bit of time to show this form. The page loads into separate frames, I should say. And if I were to maybe refresh the page and just try to identify get to this form dialog here, I will, let's see, let me just clear that thing. How can I clear it? I don't even know how. If I were to use something more dynamic, this is the object home. No, where is it? Desktop layout controller. I'll have some hooks essentially that are saying wait for something to happen. Oh, it looks like it's frozen. Too bad. But essentially, the team building the page object have a couple of methods which tell you to wait for something to happen. So you can look at the URL change, which is kind of easy, but some things are more advanced, looking at specific page elements, like saying if there's a div that is filled that has some children, you just know that you can proceed. If it's not there yet, just wait. And UTAM, just like the other test runners, have a couple of strategies. They can do retries. There are also some timeouts so you can configure to fine-tune a bit the execution to deal with the asynchronous nature. But again, it's not because a test fails once that the app is broken. You probably need to run it a couple of times and look at patterns. If something is consistently failing, maybe you need to adjust your test to reflect that.
Thanks.
Sure.
What makes you look more efficient compared to the other UAT like Jest?
So it's very different. Jest doesn't do end-to-end testing because Jest is really for unit testing. Jest, when you do Jest tests, you need to have access to the source code of your page. So you're really in a white box model. With UTAM, you're in a black box model. You don't have access to the source code of the thing you're testing. So that's really a key difference here. Also, Jest doesn't use a browser. Jest uses a purely virtual environment. So it can run in headless mode, but it can run without any browser installed. However, UTAM, when it's used with a test runner, needs access to a browser. So it can control it programmatically and actually do the real thing on the browser itself. So that's really a key difference here. Again? Oh, go ahead.
Sorry, I don't want to hog the questions.
No,
but
go
I
ahead.
always have lots of them.
Sure.
One thing that appears to be the case is that although you've abstracted the HTML and the DOM structure,
Yeah.
It is still very much tied to the page structure in the sense that you have to navigate through the hierarchy of the components
Yep.
to get to your elements. Is that true, or is there
It is true.
other ways of getting through?
And one of the key reasons why this is true is that we have a lot of web components, and the web components have this thing called the shadow DOM, which essentially shield the inner side of the component from the upper side of the DOM tree. There's an encapsulation, and to navigate through all of this, essentially you need a combination of page objects. However, what's nice with UTAM is that sometimes you have shortcut methods which allow you to traverse 2 or 3 elements to go directly down and skip all of the intermediate components. So that's very helpful, I think. But that's really the power of UTAM, is the whole modularity and composition, which helps you save a lot of time. From a web page, I can directly go and access a menu item here without having to look through maybe, I don't know, if you just take, for example, a tab here, you can see that it's already deep down a lot. And normally I would have probably to explore maybe 3 or 4 level downs, but it's here with a page object. I can directly go and select my element and go through it. And it'll figure out how to chain the different base page objects that are in the middle.
Two questions really, Philippe. Does it work with Flow, and then does it work with Lightning Communities?
It's a great question, and that's really something I'm looking forward to. The Flow team hasn't shipped their base page objects yet, so that's going to be, I think, a revolution, because once we have it, we'll have a proper tool to do testing for screen flows, for example. So I'm very much looking forward to it. There's a thread on the Trailblazer community about this, and I think they'll update us when they have when they are ready. Sorry.
Thank you. And then communities?
I don't know, actually. I never tried. There's no blocker. It's just a matter of the team taking enough time to do it.
Well, if they use those base components, does that mean they should work? And then you mentioned then it could work on any page. So if it doesn't,
the base components, yes, you could use the base components. Now,
Okay.
the upper level, like the navigation, all of that, I don't know if it's available yet. But I don't think it's too complicated compared to Lightning Experience. I think we should get them easily.
You support modularization. Do you parameterize those modules as well? So if you've got the same Lightning Web component on different pages and you're injecting different values into the slots, can you use the same test?
Absolutely, yes. Some of these page objects have methods with attributes. And for example, when you're looking at let's say this, to take again the example of a record creation form, you can parameterize some of the methods. Like for example, if I wanted to select the third component on the second column, I could trigger and add some parameters dynamically to do that, yes.
So given that it uses like a full browser in the UI, how do you script this to work as part of a CI process or build process?
Yeah. So what I did during the demo was I was showing the real browser, but what you can do is trigger it in headless mode, so it can run without a screen. But it will do the same thing behind the scene. And what's really nice here is that this is really disconnected from UTAM. This is really the test runner itself. It's not even UTAM, but it's controlling the browser again. I was using WebDriver IO, and in the example I shared, I was using Chrome, but you're not limited to Chrome. You can use any browser. So you can run the same test on I don't know, for a mobile. You can run it on Firefox. You can run it on Edge or whatever. It's just a matter of writing the configuration. And, well, I can show it to you. There is a, where is it? It's wdio.conf. This is here where I have my Chrome driver configured. And there's a number of parameters I can do, and I can even put it in headless mode. I think yes, here, for example, here. If I were to uncomment this, I can run the same test in headless mode. So no, the browser won't show up. Let me do it actually. I can show it to you. I mean, you won't see anything, of course, but you'll still see the test moving. Well, it's going to be a bit verbose, but what is happening is that it's exactly the same test we had before, but it's headless mode. So that's what you would have on a CI system. And normally it will succeed. Looking at the different elements, pinging the page, waiting for reload. And there you go, it passed. So what's really nice with this is that you can really test a lot of different browsers and no additional effort, just a bit of configuration to load other instances.
Sorry again.
Yes.
How easy is it to write your own page object JSON files? Is it relatively?
It depends on the complexity of the component itself.
You know, with the shadow DOM and all its nuances, like if you know, because of the CSS scoping rules with the shadow DOM, since web components became a thing, is it still like reasonable to expect a developer to be able to do it? A developer who doesn't understand the nuances of a shadow DOM?
Well, you don't have to deal with the shadow DOM itself, so at least that part is not too complicated. Writing the page object isn't too complicated. What's more complicated is to control the configuration of the runner itself, like all the tooling that goes around it.
I was hoping that I wouldn't see references to style sheets there, but there was still CSS references. So
well, you do need to hook yourself to the page. So sometimes you have to do that, do a bit of CSS selection, but it's never really complex. Here you can see I'm directly selecting an element. I don't have to go to do deeply nested selectors here because of breaking the complexity. Essentially, we're calling. We have child and parents, so it's always short CSS selectors, and then a dependency to another child page object, another child page object, etc. And sometimes, well, methods, like I said, like for example this one, which allows you to chain information. So here, for example, I'm on the product tile list, and I can have directly a helper method which will call my paginator subcomponent and extract directly the text. So composition and sometimes methods for shortcuts.
Thanks.
But yes, UTAM is simple on its own. The real problem is all the tooling around, because the test runner is not something simple to configure, really. Any last question? All right. Well, thank you, everyone, and I'll be here if anybody has a question. Thank you.
Eden with Salesforce is a game changer, an easy-to-use financial package that provides advanced features that you simply can't get from Xero or QuickBooks. It's based on a simple truth that integrating your finance and CRM systems on Salesforce is efficient. All your data's in one place. There are no integrations. Dashboards deliver your reporting without complicated Excel spreadsheets. Native Salesforce automates the mundane. Implementation is quick. In one VAT quarter, and minimal training is required. There are 3 versions: free forever, economy, and business class, which adds more sophisticated features and multi-companies. And it's all backed up with a 12-month, no argument, money-back guarantee. Thank you for listening.